This is my brand new Kaggle account where I'm only allowed to participate in Kaggle competitions. Now, according to me, the best way to ramp up your machine learning skills to almost 10 times better and fast is through Kaggle competitions. And the motto of this video as well as this series is how I look at the data, how I understand it, how I approach the problem, how I write code, and at the end also testing out multiple different models and also showing you how I submit files. Now, for this video, I will be participating in the very first Kaggle competition that pops up for any brand new account, the Titanic dataset machine learning problem. Now, for this one, you don't have to do any sort of verification or any sort of acceptance. You just have to get in there and then you can already submit your predictions. So first, as you click on the Titanic dataset problem, it's just going to give you a deep description, and this is what I call as level 1. You have to gather as much information as you can before you even perform data analysis and pre-processing. So I have read this entire description. Basically what it says is we have to predict the people who are going to survive and the people who are not going to survive on the Titanic shipwreck. And so they've given us information about the data itself. They're going to give us a train test and then a sample submission file as well, showing us how the submission file should be. So in order to gather information about the data, you just click on the data tab, and then over here, when you look at the data dictionary, they have given us all of the different parameters and what they represent. So here's the one that we have to predict. We have to build a classification model that can classify whether a person has survived or not. And the other parameters giving us some conditional value as well. So right as I look at this one, these are the ones that I feel is going to give us values. Whereas if you come down and look at the actual data itself, if you look at the train CSV data, we've got a name column, and this column is not mentioned in the data dictionary. So what I feel is we can drop this column itself. This is not going to give us any value in terms of predictions. And again, for me, this ticket column also has least amount of value, so I'm going to drop that off as well, because I've got more information from P class, and then I've also got the cabin number and then the ticket fare that they have paid. So I can just easily drop the ticket number, because it is only going to contain numbers and letters here and there, which is not going to give us any value. We already know the cabin number as well. Before performing any sort of analysis, I have understood that I can drop off ticket column and name column. Now, with that said, we can start off by importing all of these 3 files onto our local machine. Again, I want to show you the sample submission file. They're asking us for the passenger ID and then if they have survived or not. Our prediction should be the survived column, and then we have to give them the passenger ID. So we have to extract the passenger ID from test set, and then we have to create a new column survived as well. So with that said, we can just click on download now. That is going to install a zip file, and we will have to extract it to the main source. Alright, so now I'm here at Visual Studio Code, where I've created a brand new folder. I'm just going to call this Kaggle 001, and that is where I've extracted all of my data onto. Alright, so what I will do here is create a new file. I'm just going to call this Titanic model.ipynb. Again, this will be a Jupyter notebook, but then you can work with a .py file as well. But then if you want to use Jupyter notebook inside of VS Code, you have to make sure that you install that extension. Now inside of Jupyter notebook, I will be importing all of the dependencies. So initially, we will be needing pandas, numpy, and matplotlib. So make sure that you have it installed. And all of the others I will tell you when we get there. So first, you just have to make sure that you have pandas, numpy, and matplotlib installed. I already have it installed. I'm just going to type in import numpy as np standard, and I'm also going to import pandas as pd, and then I will also import matplotlib as plc. I'm just going to have this code cell to be importing all of our dependencies, so I can just directly run this code cell. Alright, so once we have imported the initial 3 requirements, we can just first load in the data. I'm going to first put in the train data, and then I will also load in the test data as well. Train and df test like that. Df train will be pd.read_csv, which will take in train.csv. Then we will also load in the test CSV as well. Now run this code cell. Now when you type in df train.head, this should show us the first 5 records. Yep, we see the first 5 records of the data frame train column. Let me just type in if survived not in df test.columns, df test of survived will be, let me initialize everything to 0. Now notice what I've done here. I've created a survives column on our testing data because it's not already initialized. And the reason why I do this is I'm going to combine the test data frame and the train data frame together as a single domain. And this is very, very important. Whatever pre-processing you do, whatever data analysis you do, it has to come from the same domain. The train set and the test set should go onto the same domain. So what I will do here is actually we see the first 5 records. Now here I will create a new function. I'm just going to call this preprocess, and which will take in df test and df train. Alright, then what I will do here is call in df will be pd.concat, use the concat function. You have to make sure to put those two inside of list, df train and df test. Then make sure to type in axis will be 0, because we're just merging them in terms of columns. All of the columns are just going to be the same. We're just making that as one data frame. We're actually vertically stacking. Alright, now we have created our main data frame, and in this data frame only all of my pre-processing functions are going to go. So first, what I will do with this main data frame is I will drop off the columns that I don't need, and I will be doing that by using the df.drop function. I will drop off name and then ticket. Alright, so when I just type in df.drop name and ticket, those two columns will be dropped off, and that will update our main data frame. Again, in order to see this in action, you will have to call this preprocess function. In fact, let me just run this. This time we should not get any output. Yep. And first, let me actually concatenate this outside as well. Copy this, paste it over here. Alright, now we have a data frame outside and in the inside. This will go as a preprocessing function, and this will be for our reference. Now here, if I type in is_na.sum, this will give us the none values in each column. Alright, now we see that we have none values in the age column, and we have those in the cabin column, and then we have a couple over Embark and one over Infa. So we will have to deal with all of these, but before that I want to show you, after dropping the name in the ticket column, how does the data look. So what I will do here is, let me just go ahead and type in reference. df will be just calling the preprocess function, and then which will take in df train and df test. df test like that, and this will give us the final data frame. So let me just return that as well. Return df like that, run this code cell, and now run this reference df.head. When you run this code cell, you should be able to see the data set without name and without ticket. So this is after dropping the name column and then the ticket column. Alright, the next thing that I'm going to do is deal with these none values. And the way I'm going to do this is by filling off those none values based upon some conditions. Like, let's say for age, I'm just going to fill them off with the mean value. So what I will do is type in df of age will be df of age, once again, dot fill na. This will fill the none values. This is the function responsible for that, and then we have to mention the value with which we are going to fill the none values, and I'm going to be identifying the mean of the age, so dot mean, and that will be it. It will be filling all of the none values with this age. Alright, so let's just run this code cell once again and make sure that this is also working. Reference df dot is_na.sum. Run this. You should be able to see no none values in age. Now for the cabin number, what I can do is, first, if you look at the cabin number itself, you can see that it has got a letter and then it has got a bunch of numbers. So I will be filling it in that format itself. This is not in the format of numbers, this is in the format of string. So we have to fill it in the format of string only. So what I will do here is just go ahead and type in df of cabin will be, again, just do the same thing, fill na df of cabin, but this time I will be just typing in x000. That is a random letter and then zeros. Alright, now let's just make sure that that also works. We do this, and now we see that we have no none values in cabin as well. We can do that for embarked. I'm just going to find the median of embarked, because let me just show you the data. It's just showcasing the letter, so we can find the median of that and then fill it. So what I will do is just go ahead and type in fact, let me just delete this data. Alright, now here I'm going to just type in df of embarked will be df of embarked, once again, dot fill na with actually finding the median. So df of embarked dot median. Actually, you know what, instead of finding the mean, I feel like we're much better off with just filling it with a random letter. Alright, so let me just fill it with x, and then we also have var as well, which I will be filling it off with mean, like that. Now when we just run this code cell, Again, I just filled the none values by finding the mean of var column. All right, so now that I've done that, now we should be seeing no none values in any column. So let me just run. Okay, first we had to call this and then call this. All right, now we see that we have no none values anywhere. Now the next thing that I'm going to do is actually separating the cabin itself, and then when you look at some other columns as well, we've got binary values, male and female, and then over here we've got 3 different values, S, C, and then if you look at it further, you're going to get much more letters as well. And then in cabin, we will be having multiple different values, and we will have to separate them accordingly. So what I think of doing is just performing one-hot encoding. But before performing that, I'm going to separate the cabin values from its letters. So I will be creating 2 new columns. One will be for the cabin letter, and the other one will be for the cabin numbers. So in order to do that, what I will do here is just go inside of the preprocess function, then type in, let's first create 2 new columns, cabin letter will be, and then I will also create cabin number. All right, so we have created 2 new columns. The first column will hold all of the letters only. So to extract that, we can use regular expressions. In order to do that, let me just first access the cabin column itself. This is the cabin column. I'm going to first convert that to string, just to make sure that it is in the string format, and then type in extract. You will have to mention the regular expression. Since you're only going after the letters, what I will do here is just type in from A to Z, and then also capital A to Z. All right, or just make sure to put in plus. This will look for multiple different continuous letters, and if it finds it, it's going to extract it and put it in cabin letters. All right, I'm going to also type in expand equal to false, because we're going to do it anyway. And then I will do the same thing for cabin numbers as well. What I will do here, just get here, then type in \d. This will look for digits and then extract that, put that in the cabin number column. All right, now we have created that. Again, we just make sure to run this and check if everything is working properly. Reference df. Oops, pattern contains no capture groups. I guess we have to put this inside parentheses. That, I like that. Yep, now when we run this code cell, run this. Oh, we have to do it for this one as well. Now this time it should work. Yep, it works. Now we should be having 2 new columns, cabin letter and cabin number, which has extracted the letter and the number separately. Now we don't need this column anymore, so I will drop that off as well. What I will do here, come here and df will be df.drop cabin, and then I will mention access equal to 1. All right, so we've mentioned that. Now let's just run this code cell once again. All right, now we don't see the cabin column itself, but then we see the cabin letter and the cabin number as 2 separate columns. Our model will like complexities like this. It will understand the data better. All right, so the next thing that I'm going to do is one-hot encoding all of the different categorical values. So here, as we see, like in terms of this column alone, we have 2 categories. One is male and the other one is female. So what I can do is create 2 new columns, male and female. And if the record belongs to male, then the male column will have 1 and the female column will have 0, and vice versa. And we can also do this for the Embark column, cabin letter column as well. So this will give us multiple different new features, and off of those features, we can remove all of the none value column as well. That is, if the cabin letter X column is 1, we can drop off cabin letter X. That is, we don't need the cabin letter X. While all of the other values are 0, then cabin letter X will be 1. Again, I will show you how this works when we get there. So first, let's just do the one-hot encoding itself, and the simplest way to do that is by using panda's getDummies function. So what I will be doing is typing in pd.getDummies from the df itself, the main data frame. Now we can type in columns equal to cabin number, and then we can also add in a prefix, which will be cabin, like that. Instead of cabin number, let me just put this as cabin letter, like that. All right, and make sure to put this inside a list. All right, I'm also going to do this for embarked as well. So let me just create one for embarked, prefix as well. Let me just change this to embarked. And then I will also do this for the gender column. So Control E, all right, like that. Now, when we run this code cell alone, after these 3 lines, we have to see a significant difference in our data set. All right, now we see that we have multiple different cabin columns. This will say if the person belongs to cabin A, B, or C, and it just goes on. And if they don't belong to any of these cabins, if the data for these cabins are not available, then cabin X will be true. And what I said before was to just drop off this column itself. Let the machine identify that if the information for all of this is not available, then it's just 0, we can't get any data out of it. Alright, the same goes for embarked as well. If embarked X is true, then we can just drop off that embarked X as well. Let the machine identify the same as it did for cabin as well. Alright, now what I will do is just drop off those two columns that I just mentioned. df will be df.drop, guess it's called cabin X. Access will be 1. Let me do that for embarked as well. Embarked. Now let's just run this code cell once again, and this again. Now we should not be seeing the X column existing. Alright, yes, we don't see the cabin X column here, and we also don't see the embarked X column here as well. Alright, the next thing that I want you to notice is when we initially look at the original data, in fact, let me go ahead and over here, let me just type in df train dot head. Here we see the cabin, and it has got C85. Let's say that this is an example where it's got letter and then numbers. What if cabin only contains a letter and then there is no numbers? There's 4 records like that. I've looked at the data by just performing that earlier, and then I found out that 4 records has only the letter and it doesn't have any numbers. Now what happens is when we split the letter and numbers separately, we will have the letter column filled, but then the numbers column will be none. So now if you actually have to look at it, just run this code cell, we see that the cabin number has 6 none values. When we combine the test and the train set, we get 6 combined none values in the cabin number, and we can just fill this with 0. So what I can do over here is just access the cabin number column, will be cabin number dot fill NA with 0, just like that. That's about it. This should fill the cabin number which has none values. So let me just run this code cell once again, then run this as well. Alright, now we see that our cabin number has no none values. Alright, so after all of that, now we have a pretty feasible data set with just pre-processing and cleaning itself. Now, if you look at the final data set, in fact, let me just run this once again and this as well. We get a data set that we can provide to the model for predictions. So let's just try that. Before we even do any feature engineering or anything like that, let's just see how the model performs on our just cleaned and little bit of pre-processed data set. So what I will do here is notice that we have concatenated the train and the test set together and then made that as df. Now in the return format, I will be returning that as train and test once again. Because test set, remember that we have crafted a new column survived and then we have initialized all of it to 0. So what we have to do here is just get the train set and then ask for the model to train on that, and we have to deploy the model on that training set only. So what I will do there is just first, after extracting this training set, I will split that into 80 and 20, where 80% of this training set will go to the model for training, and then 20% of this training set, we will use it for testing the model. Right, so df of train, this will be our return format. df of, from starting till the end of df train, the first train values is what we're going to get as our train set, and the rest is going to be our test set, like that. And then before returning that, what I will do is I will drop off the column df of test, will be df test dot drop survived, because we don't need a survived column, it has to be non-initialized, we have to predict on that. Alright, let me just mention access equals 1, like that. Alright, now I'm going to return df train and df test like that. Now run this code cell, that is our pre-process function. Now this will get our df train and df test back, so let me just write it in reverse. Df train, comma, test data frame will be this, cancel this thing out, and then delete this one as well. Alright, now when you just run this code cell, we're going to get train df and test df. Alright, now from the train df, I'm going to extract our x and y labels. So our x will be train df. Actually, let me just do that in a specific separate code cell. We'll come over here, just do that in a specific code. So df x will be, our x label will be train df dot drop survived column, because we want all of the data without the survived column, and then access will be 1. And then our y label will be train df of survived column, of survived, like that. Alright, so now we have our x label and our y label. Now I will do the train test split. Now from this point on, we will need scikit-learn. And you can just go ahead and type in pip install scikit-learn on your command prompt, and then it will install the package for you. So just go to your terminal and then type in pip install scikit-learn. So what I'm going to do here is just go ahead directly and type in from sklearn dot model underscore selection import train test split underscore so. Alright, now we have our train test split installed. This will be the function that we'll be using to split the data into 80 and 20. I'm just going to call this xtest, actually xtrain, comma xtest, ytrain, ytest. All of these 4 columns, which will be, we will call our train test split function, train test split, which will take in x and then our y label. Let me have my test size to be 0.2. That should work. And then now let me just run this code cell once again. Now if you type in xtrain.shape, comma ytrain.shape, run this. We have 712 records on both sides, but then we would like to have this as 2-dimensional. So what I will do here is just type in, actually, inside of this, let me go ahead and type in ytrain.reshape. Let me just go ahead and type in ytrain. Will be, let me update that to np.reshape function and then use it ytrain. Now we will also have to mention the size. We can have as many rows as we wish, but then we have to make sure that there is only 1 column. Let me close that and run this. Alright, now that works. Now when you run this, we get a 2-dimensional shape. Now, from scikit-learn, I will be first importing the logistic regression model and see how the model is performing. So from sklearn dot linear model, we want to import logistic regression. Alright, now update and run this code cell. Now we will use that. That is our model 1 will be, this will be our first model, logistic regression. And then I will type in model1.fit to pass in our xtrain and ytrain, like that. After we've done this, let me actually run this code cell. Alright, now when we see this logistic regression, that means that the model is created. Now we can make predictions on this. Now, all we have to do is just type in model1.predict, and then we have our xtest variable. Now this will give us predictions in terms of ypred, and we can compare that with our original labels, and we can do that by using the accuracy score from scikit-learn. We will have to import that one as well. So we get to the cell where we import all of our dependencies. So from scikit-learn dot metrics, we will import accuracy score, like that. And run this code cell. I have imported the accuracy score, and then let me just go ahead and type in accuracy score of ytest and ypred. We have passed in the original variable and then the predicted variable as well, and then we can see the accuracy score. And when you run this, oops, ypred is not defined, we have to run this, and then we have to run this. Alright, so we see that the model is giving us 80% prediction without doing any feature engineering. I consider this a fairly decent one, but then I feel like this could get better. So let me just try that with another model. Let me actually use XGBoost this time. Again, you have to install XGBoost as well, but I have already done that. If you haven't, just type in pip install XGBoost on your terminal. Again, if you haven't done that, just go to your terminal and type in pip install XGBoost. This is another library which uses decision trees to perform classification tasks and also regression as well. But for this one, we will be using XGB classifier. Since I already have it installed, I'm just going to directly import it from XGBoost. We will import XGB classifier. This one. Alright, so now we have imported the classifier. Let me just create another new model. It's just very similar to what we have done above. Just go ahead and type in model2 will be XGB classifier, and then we can just go ahead and type in model2.fit xtrain and ytrain, like that. And you run this, we get an error. Enable categorical must be set to true. All right, so let me just go ahead over here and just type in enable categorical will be equal to true, like that. Now when you run this, we should be able to see the model itself. Why is it not working? Okay, so instead of trying this, instead of typing in enable categorical equal to true, we know that we only have floating point numbers as our cabin number. What we can do is just convert this cabin number to maybe, let's say, a pandas numerical object. So to do this, what I could do is go over here, df of cabin number will be equal to pd.toNumeric. This will now be a numeric object of cabin number, like that. Close it. Alright, so now we have converted the cabin number to a numerical value and then stored that to our cabin number column. This should now be working. So let me just run this and then run this. Now if we see our model 1 predictions, it gives us 87%. Okay, so when we run it multiple different times, you will get a mean value of how the model is performing on this test set. But then I've done that just to rerun the file to convert that to numeric. Now yes, we do get the XGB classifier model as well. Now what I'm going to do is just go ahead and type in ypred is equal to model2.predict xtest. Alright, tab 9 recommendations. Alright, and this one as well. Alright, now when you run this, so our model 2 gives us 82% prediction, but I feel like we could do a little bit of feature engineering and get this up as well. But then just for the sake of it, I'm just going to run all once again and see the accuracy score. For model 1, it is 78% this time, and then 78% for this one as well. So there is a lot of noise here and there. So what I wish to do is give it more obvious features for the model to actually identify the conditions or the value proposition of each and every feature. Again, if you don't understand what that means, I will show you right about now. Alright, so what I will do here is we have got the train df and the test df. So here I want to find out from the train df, I want to find the correlation of all the models with the survived column. That is, how much value is it providing to the survived column. And to do this, what I will do is type in df.core. This is a function which is to identify the correlation, and then you have to mention the column as well. Alright, and this is not df, it will be train df. When you run this code cell, you will see the survived column as a 100% relation to the survived column that we mentioned, which is very obvious. So that is how correlation works. I want you to look at p class. Now when it says negative, that means that more smaller the number, more chances of the actual column that we're trying to predict is 1. So when the p class number is low, it gives us a 33% indication that the person might survive. That is how we find the correlation of each and every single column that we've got. And then from over here, we see that the very strong indicator is p class. And then I also see that the gender part for some reason gives us maximum correlation as well. And then I also see cabin number, which is okay-ish. We see the cabin number, and if it's higher, we get a more good chance of the person is going to survive. We also look at the fare, more the chances of them is surviving. Alright, now with this data, with this information, I will be crafting new features. And the way I do this is by looking at all of the ones that give us maximum value, and I see that, let me first look at this one. This is p class, and we can correlate that to fare. That makes more sense. Alright, so I'm going to combine these two columns, p class and fare, and create a new column. I'm going to just call this p class bin underscore fare. Alright, and this will be df of p class, or let's say fare, and I will divide this by, alright, so I'm just obtaining the fare, and then I'm also obtaining the p class as well. That is the fare, let's say if it's 1000 units, and then if the p class is, let's say 2, if we divide that, that's going to give us a number of 500. So this should give us a positive correlation, or maybe negative. That doesn't matter, the number should be big. Alright, so now when I run this code cell, and then run this one, and run this one, now we see that we have a new column, and that correlation has 26%, which is actually really, really nice. This is giving us positive indications to the model itself that it can make better predictions. Now, on this side itself, let me just create another feature, p class, let's say p class bin, and then I can access the gender as well. And as I see over here that it says that if the person itself is a female, then they have 54% chance of surviving. So what I can do is, we have created two categorical columns, one for female and one for male. So if the female column is 1, we can just subtract that from p class, because that is going to give us a realistic number. I'm just making these correlations up. You can try dividing it, you can try multiplying it, you can try any type of method that you wish. For the first one, I divided, and for this one, I will be subtracting to get a single valued number. I'm just thinking it with an example in perspective. All right, so p class minus female, or what is it called? Just copy this, paste it over here. All right, now we've created another new column, and this should again give us a strong indicator as well. Why is it taking too long? Gives us an error saying p class is not found. Okay, type it like this code cell, on this one, and now run this. Now we get 2 new columns, and this as well is giving us around 53% of strong indication to identify the final variable. All right, now this time, after constructing 2 new features, let's try that with these 2 models. Just make sure that they are of the same shape. All right, I'll create the logistic regression model, make predictions, and see the prediction rate, and it's giving us right around 80%. Let me just do that for model 2 as well, and then identify, and still it remains at 78%. Let me just run all once again. All right, it keeps going further and further, and still we can't reduce the amount of noise. So we have to continue to identify all of the new features that we can create. But then for the time being, I'm just going to leave it as it is. Maybe I will construct 2 new models as well. So we will create model 3 and model 4. And over my knowledge, we can also use random forest classifier. Again, that is another one which uses decision trees to identify classification. And this is pre-built in scikit-learn itself. So again, from sklearn.ensemble import random forest classifier. All right, like that. Now run this code cell. We'll create a third model. Model 3 will be random forest classifier. Model 3.fit takes in xtrain, comma ytrain, like that. This should take in some time. Yeah, all right. So we have the random forest classifier model as well. Let me just try to predict for that one. Predict x-test, and then we can predict the accuracy score for this one. All right, now let's just run this code cell. And this gives us 83.7%. Let me just run that once again. And this time it gives us 84%, while if I compare that to, let's say, model 2, it's giving us 81%, and this is at 78%. So when I compare that to the first 2 models, let me just do that once again, just to be absolutely clear. All right, so this is always about 80s, while this one fluctuates around the low 80s and the high 70s mark. So I'm just going to go with model 3, that is the random forest classifier model with the provided data, and then I will make predictions with that. So inside of this code cell, what I will do is create a new CSV file which will extract the passenger ID. Again, just remember that the submission file format should have the passenger ID, and then it should also have the predictions. So to do this, what I will do is, again, update the prediction variable model 3.predict xtest. Instead of xtest, let me just pass in the test df. All right, we have our test data frame. Notice that we extracted that from the preprocess function. If I could show you, it's right around here. We have extracted the test df, and then we are going to identify the predictions for those by using the model 3. And then let me just give it a name. Final will be pd.dataframe. So create a blank data frame. All right, so inside of this final, we'll first have passenger ID, which will be extracted from the testing data, will be equal to test df of passenger ID. All right, now we have our passenger ID, and then final of survived column will be our prediction, just like that. And then to just simply create a CSV file, you can just type in toCSV function, which I will call it as output.csv, and then I will mention index equal to false, because our index is just going to be the passenger ID which we have created. We don't need a random index. All right, now when you run this, we should be able to see a new output CSV. All right, we get that over here, and then this should match to the passenger ID and survived column. Alright, so now we have this output CSV. We're going to make this as a submission and see our results. Now over here, we will just want to click on submit predictions. I will drag and drop the output CSV file, or output.csv, click on submit, and this will give us a leaderboard. Alright, so now it gives us a score of 76.55%. If you look at that on the leaderboard, jump to your position on the leaderboard, we will find us somewhere on this column. And now when you look at the top percent in the leaderboard, we see that there is 100% accuracy, which I feel like is forced. I don't feel like this is realistically possible. A model will never be able to predict 100% of the data unless it is provided much more data than we actually had. In fact, if I have to go to my main account and show you my initial predictions, I was able to go as high as 79.186%. If I look at that in the leaderboard, that will put me at around 1076. Again, so this can definitely be improved. You can create much more new features, and then you can also try different models as well. There is again a decision tree classifier and support vector machine and much more classification algorithms that is there in scikit-learn itself. And then you can also nevertheless just create multiple different new features and also try to understand the data a bit more. I will also provide the data file that got me 79.186 in the description box below. Alright, that's about it. We will see you in the next CAG series.